Okay, children. So today we will discuss about the prism activity. Exclusively, total prism activity only we will discuss. In lab, how we will do prism activity. I will explain prism activity. First, you see, children. Normally, what happens in prism means normally I am not telling activity. See, air is rarer, glass is denser. Glass is denser, air is rarer. This is one normal. This is also one normal. Normal means 90 degrees to the surface. Normal means 90 degrees to the surface. If light ray is coming like this, rarer to denser, we know it moves towards the normal. Yesterday I was telling. Rarer to denser, it moves towards the normal. And denser to rarer, it moves away from the normal. Away from the normal. Okay, like this. Those who didn't understand, again I'm telling, see here. Those who didn't understand, please check here. Normally, how it will be, this is normal, this is normal. Normal means perpendiculars. Imaginary lines, it won't be there. Okay, so light ray comes like this. Rarer to denser, it moves towards the normal. Denser to rarer, it moves away from the normal. Normally it happens. Suppose this prism was not there. What happened? What would have happened? This light ray would have gone straight. It never used to bend. If this prism was not there, I am saying. If you extend this angle, this is called angle of deviation. What is angle of deviation? It is the angle through which this is deviated. It is the angle through which incident ray is deviated because of prism. And this is called angle of prism. Okay. What is angle of deviation? Again, I am saying, if prism was not there, light ray would have gone straight. But because of prism, it is bending by this much angle. This is called angle of deviation. What is angle of deviation? Is angle between incident ray and emergent ray. Is angle between incident ray and emergent ray. Is angle between incident ray and emergent ray. It's called angle of deviation. Now, how we will do the activity? I will explain. See here. In lab, how we will do the activity? Simple, children. This is a prism. This is angle of prism. Okay. Here we will draw one normal. Here we will put some incident ray. Remember, always incident ray should be between, you should take between 30 to 60 degrees only. Not less than 30, not more than 60. Not less than 30, not more than 60. We should take between 30 to 60 only. Incident ray. Incident angle, it should be between 30 to 60 only. Incident angle. What is incident angle? This is angle of incidence. It should be 30 to 60. Now here you keep two pins, minimum at a distance of 2 to 7 centimeters. Two pins you keep here. Pins. See from this side, that pins. See from the other side of the prism. Here your prism is there. No? See from the other side of the prism. When you see from the other side of the prism, these two pins will appear somewhere. Wherever you feel appearing, you put there two dots. Now you join these two dots. After joining these two dots, at this point of intersection, draw one normal. After drawing normal, join this. This is angle of incidence. This is angle of emergence. This is refraction 1 and this is refraction 2. Refraction 1, refraction 2. Now if this prism was not there, light ray would have gone straight. But because of prism, it is deviating by this much angle. This is called angle of deviation. I am telling you from that time. Now imagine this is x, imagine this is y, this angle. It's not there, just imagine. Now slowly I will say the derivation, all of you see here. External angle is equal to sum of interior opposite angles. This is in this triangle. Can you see in this triangle? There is a triangle here. In this triangle, exterior angle is equal to sum of interior opposite angles. D is equal to x plus y. Just keep it aside. D is equal to x plus y. Okay. Now you see, we know from the parallel lines, vertically opposite angles are equal. Means I will be equal to x plus r1. This and this are vertically opposite angles. Vertically opposite angles are equal. Means this angle will be equal to x plus r1. In the same way here also. Vertically opposite angles are equal. Vertically opposite angles are angle of emergence is equal to y plus r2. Y plus r2. Now x we can write as I minus r1. Y we can write as y we can write as e minus r2. this x and this y, substitute in deviation. Here you substitute. Girls, are you able to understand? Girls?
Yeah, sir.
Yeah, sir.
D is equal to x plus y, you understood?
Yeah, sir.
And I is equal to x plus r1 is vertical opposite angles are equal. E is equal to y plus r2, vertically opposite angles are equal. Substitute this and this here. So D is equal to x is I minus r1 and y is E minus r2. So D is equal to I and E. Okay, I plus E minus r1 minus r2. Okay, now D is equal to I plus E minus, if I take common, r1 plus r2. Now you check one more derivation. Suppose if I join these lines, this, 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 this will become a quadrilateral. Okay, girls, this is a quadrilateral. You can see here.
Yeah, sir.
Okay, so in this quadrilateral, what will be this angle, children? Opposite angles will be equal to 180. In a quadrilateral, opposite angles will be equal to 180. Okay, because it is a parallelogram. This and this are parallel lines. So this and this are parallel lines. So it is a quadrilateral. Opposite angles are parallel lines. It is a quadrilateral. So this plus this. So let me say this is K. Let me say K. So slowly I'm saying, listen. K plus R1 plus R2 is how much, anyone? K plus R1 plus R2 is how much, anyone? K plus R1 plus R2 is how much in this triangle? Angle some property.
180.
180.
Angle some property 180. What can I write K? A plus K is equal to 180 because opposite angles are equal. Opposite angles are equal normally. Okay, sum of opposite angles will be equal to 180. Sum of opposite angles will be equal to 180. So this plus this will be equal to 180. So K I can write as what? K I can write as what? 180 minus A. This plus this is 180. This plus this is 180. This plus this is 180. So K I can write as 180 minus A. That I will substitute here. 180 minus A plus R1 plus R2 is equal to 180. 180, 180 cancel. A goes here. A is equal to R1 plus R2. Okay, this A you substitute here. So deviation is equal to I plus E minus A. Deviation is equal to I plus E minus A. So children, now two formulas I told you. What are the two formulas? Means this is one formula and this is another formula. Angle of prism is equal to R1 plus R2 is one formula. Angle of deviation is I plus E minus A. Angle of deviation is I plus E minus A. Two formulas I told you. What for you told these two formulas means I will tell you. You have to draw a graph. If you draw normally, when you are doing this experiment with different angles, we will take 30, 35, 40, 45, 50. We will take here angle of incidence we will take, and here we will take angle of deviation. If you draw, children, we have to do once for 30 degrees, once for 40, once for 50, once for 60. 4-5 times we have to do this experiment, and 4-5 times we have to draw the coordinates. If you draw the coordinates, it will come like a parabola like this. At one point, this is called minimum. Means this deviation is there, no? Minimum, small deviation. This is called angle of minimum deviation. At this angle of minimum deviation, this is called angle of minimum deviation at this point. Okay, what is that point called? Angle of minimum deviation. At angle of minimum deviation, when deviation is least at that point, I and E will be equal. You should remember. I and E will not be equal normally. They will be equal only when deviation is least. I and E will be equal, and R1 and R2 also will be equal. When they will be equal, only during deviation is minimum. Okay, don't worry. I will tell you again. Don't worry. So children, we will do experiment. We will do once we will take 30 degrees, once we will take 40 degrees, once we will take 50 degrees, once we will take 60 degrees. Like that. When you are taking 30 degrees, how much is the deviation? We will measure. Let me say something you got. When 40 degrees, something you got. When 50 degrees something you got. When 60 degrees something you got. For all the graphs will be like this. This point indicates smallest deviation. Among all the deviation, this is the least deviation happened in our activity. In our experiment, this is the smallest deviation. During this, remember, when deviation is the least, angle of incidence will be equal to angle of emergence. Remaining times they are not equal. And only during minimum deviation position, R1 and R2 also will be equal. Remaining times it will not be equal. Okay, and during minimum deviation, what will our formulas will become now? What our formulas will become? First formula, I plus E minus A. During minimum deviation, these both are equal. So I plus E I can write as 2I minus A. Only during minimum deviation, children, not always. A, if you bring D plus A is equal to 2I, bring 2 down, I is equal to D plus A by 2. This is only during minimum deviation, not always. So first formula became like this. What is our second formula? A is equal to R1 plus R2. What happens during minimum deviation? R1 and R2 will become equal. A is equal to 2R. R will become A by 2. Okay, and finally, we have Snell's law. What is the Snell's law we have? Anyone, do you remember anyone Snell's law? Yesterday I told sin I by sin R.
Sin R.
What is sin I now? What is sin I? Sin of d plus a by 2. And what is sin R? Sin a by 2. This is also formula for refractive index only. The other refractive index formula is this. This is the prism derivation. And on what factors this angle of deviation depends? On what factors angle of deviation depends? That is also an important question. Angle of deviation depends upon first one, angle of incidence. Second one, material of the prism what you are taking. Third one, angle of the prism. Fourth one, color or wavelength of the light. Wavelength of light or color of the light which we are using. Okay, how it depends, sir? You'll ask. How it depends? How it depends? You will ask. No. How it depends? Deviation in different angle. As the angle of incidence is increasing, deviation first decreases, then it increases. Okay. So as the angle of incidence is increasing, deviation first decreases, then increases. Last time I'm saying, as the angle of incidence is increasing, deviation first decreases, then increases. That is first one. Then how it depends upon material, sir, you will ask. Okay, so how it depends means, like suppose it is found that a given angle of incidence of prism, higher refractive index produces greater deviation. More refractive index, more deviation will be there. More refractive index of the glass you take, more will be the deviation. And how does it depend upon angle of prism? Okay, angle of prism increases with angle of it is so more is the angle of prism, deviation also increases. And last one, color. How does the color? How does the color? So a given prism deviates violet light the most, no, and red light least, no. So therefore, what we can say, it decreases with increase in the wavelength. Deviation decreases with increases in the wavelength. You will say, sir, we need to understand. Explain what. I will explain. Easy thing I will explain, children. Easily I will explain this one. How means see when you are passing white light to a prism, among all 7 colors, what you get there, here red will come, here violet will come. Which deviated most? Violet. Which deviated least? Red. So wavelength of red light is maximum, children. Remember, that's why it is used in danger signals. In danger signals, they put red only because it has longest wavelength. Because it has longest wavelength, it deviates least. So, what are the factors of angle of deviation? Angle of incidence, material, angle of prism, wavelength. With material, it increases. With angle of prism, it increases. With wavelength, it decreases. With angle of prism, it increases. With material, it increases. With wavelength, it decreases. And angle of incidence, as the angle of incidence is increasing, deviation first decrease, then increase. This is entire prism activity, what we do in our lab, children. So slowly I will explain all the topics. Slowly listen, children. First, D is equal to x plus y because exterior angle is equal to sum of interior opposite angles. I is equal to x plus r because vertically opposite angles are equal. E is equal to y plus r because vertically opposite angles are equal. X I wrote I minus r1, y I wrote e minus r2. This x and y I substituted here. I got this formula. And next, A plus k will be 180 degrees because opposite angles are supplementary. Opposite angles are supplementary. So k is equal to 180 minus a. That k is equal to 180 minus a. If I have a second formula, I got a is equal to r1 plus r2. But r1 plus r2 is a, so d is equal to I plus e minus a. Two formulas are this. These are the two formulas. First formulas. At minimum deviation position, what happens? I and d will become equal. Incidence will become like that. At minimum deviation position, R1, R2 also will become equal. R will become like this. So Snell's law formula, sin A plus D by 2 by sin A by 2, because sin A by sin R, I is this much, R is this much. And on what factors deviation depends means angle of incidence, material, angle, wavelength. Angle of incidence, material, angle, wavelength. Angle of incidence, material, angle, wavelength. Okay, with material it increases, with angle of prism it increases, but with wavelength it decreases, and with the angle of incidence, first it decreases, then it increases. At one point, least decreasing is called angle of minimum deviation. At angle of minimum deviation, I and E, this and this angles will be equal. Remaining positions, they both are not equal. Only at minimum deviation, this and this are equal, this and this are equal. Girls, anyone have any doubt? You can ask me. Any line, any word, any topic. Among all this, if you have any
Yes,
doubt,
sir.
you ask me. If you don't have doubt, what I will do means I will do some numericals on this. I am sending the picture also because you were requesting with the picture. I am sending this picture also for you. Mm, see, I am sending. Okay, that will be helpful to you. And now we will do some questions based on this so that you will have some clarification. Without rubbing, I can't do, children. Shall I run?
Yeah, yes, sir.
So some questions we will do. Yeah, I'm rubbing, children. So we will use accordingly whatever question comes. Whenever any question comes,
No, sir, no doubt.
yeah, that's first question. Question is like this. First question. They are saying this is a prism. Okay. Alongside a equilateral prism. Equilateral prism means girls 60 degrees, 60 degrees, 60 degrees. Angle of prism is 60 degrees. Indirectly, he said. A ray OQR is emerging like this. A ray QR is emerging like this. A ray QR is emerging out from the prism after suffering minimum deviation, he said. It is suffering minimum deviation, he said. During minimum deviations, I and D are equal, R1 and R2 are equal. You should remember that point. I told you just now. Complete the diagram to show the refracted ray PQ inside the prism and incident ray OP on the prism. State in words how have you completed the diagram. So see, children, just is asking to draw the figure, children. That is very easy, no, children. So here we will draw normal. Okay, and this is rarer, this is denser. So denser to rarer only, it moves away from the normal like this. We'll put here, we will draw one normal. Okay, this is denser, this is rarer. Denser to rarer only, rarer to denser, it moves towards the normal. So like this. This is angle of incidence, this is angle of divergence, this is refraction 1, this is refraction 2. Like that. You have to explain denser to rarer, rarer to denser, what is happening, you have to write. That is first question. One more question we'll do, children. Second question. Okay, so here there is a prism, this is a prism. Here is a source of light, here is an observer whose eyes are there. This is eye. Here is a source. A monochromatic point source of light S is viewed by an observer O through the prism. Complete the diagram to show the image formed by the prism and as seen by the observer, label the image by the letter I. So children, he is asking one monochromatic light. What is monochromatic light, children? Do you have any idea? Monochromatic light means one color light, not white light. White light means it will have seven colors. Monochromatic light
Yeah,
means
sir.
any one color light, any one color light. Red you take, yellow you take, violet you take, green you take, your wish. One color light you take. What happens, girls? Normally, what happens? So it will go like this, reaches to the eye of an observer. But same light ray when extended back For him, this light appears here. The same light I will extend back. This light which was there here, for him it appears here. That's it. That's it, guys. We have to show with the diagram. That's all. Nothing else. When we extend this back, for him, for that fellow, this image appears here. Third question. Third question. So, children, here is a prism. Here, they have kept an inverted prism. Okay, what happens? He is asking. What happens? Here is a prism. So, children, simple children, nothing. See here. Rarer to denser. Towards the normal. Denser to rarer. Okay, children, denser to rarer. Away from the normal. Like this, it will fall. Now, at this point of incidence, draw one normal children. Again, rarer to denser. What happens, children? It will go rarer to denser. What happens, children? It will go towards the normal. Again, here you put denser to, this is denser, this is rarer. Denser to rarer, away from the normal. It will go like that. That's it, children. You should have that confidence in drawing. Rarer to denser, because this is denser, this is rarer. Denser to rarer, it go away, children. Okay, okay. If you are understanding, one more question, children. See here, they have given one right-angled triangle, children. Right-angled triangle. This is 60 degrees, children. If this is 90, can anyone say what will be this angle? Anyone? Yes, I asked simple question. If this is 90, this is 60. How much will be this, girls?
Sir, it'll be 80 minus 90 plus 60.
How much?
Sorry, 180 minus.
How much? 180 minus 150. How much?
That will be 30 degrees, sir.
30 degrees.
30 degrees, sir.
Now question is, here one light ray is coming perpendicularly, it is hitting perpendicularly. Question is now, he is asking you to draw the refracted ray inside. Refracted ray inside, how it goes, he is asking. Shall we draw, girls? So children, because it is hitting at 90 degrees, it will not suffer any refraction here, it will go like this straight. But here what happens? Draw one normal. Draw one normal. If you draw normal, children, see, it will be like this. Children, this is 90. This is 90. Try to understand. Girls. Okay. So this is how much? 60. So this will be 30.
30.
Now what happens? So what will be this angle? What will be this angle? What will be this angle? This is also 90. This is how much amount? This is 60. Okay. This is 60. This is 90. 90 plus 60 is how much? 150. So this is 30.
30.
Now see here. This is hitting at 30. Now this is denser. This is rarer. Denser to rarer, it moves towards or away? Away from the normal, it goes like this. Away from the normal, it goes like this. When it is going like this, they are asking you, what they are asking is, what will be this angle? That's all. That's all, children. He is asking this angle actually. This angle is how much they are asking. That angle is 30 degrees. That's all. You have to show that is 30 degrees. Okay, children. You have to show that is a 30 degrees. This angle they are asking how much in the question textbook they ask this angle is how much between normal and this is 30. How you got? I show you. One more like this, children. If you didn't understand, one more question. The angle of the prism is 30 degrees, children. The angle of the prism is 30 degrees. One light ray is coming and incidenting at 90 degrees. Okay, angle of prism is 30 degrees. One light ray is coming and incidenting at 90 degrees. So when it is coming like this, because 90 degrees, it will come straight like this only. So this is also 90. This will be how much, children? 60.
60.
Draw normal at this point. So this will be how much, girls? 30.
30.
Denser to rarer, it moves away from the normal. Denser to rarer, it moves away from the normal. That's all, girls. They are asking you this angle is how much. This is 30 over. That's all they are asking. And you have to draw this ray also. It's showing outside now. That's all. They are asking this angle is how much in the textbook. This I am writing, you should not write in the exam. This I am writing, you should not write in the exam. This 60. They are asking only this. This 60 you should keep in your mind.
Okay.
Next question. Next question, children. This is a prism. This is a prism. This is 45 degrees. Light ray is coming like this at an angle of 70 degrees with the base. That's not angle of incidence. Question is completely diagram. So children, at the point of incidence, you should draw normal. This total is 90. 90 minus 70 is how much, children? 20.
20.
Okay, so children, this is rarer, this is denser. Rarer to denser, it moves towards the normal, towards the. Okay, so what they're asking means now this one, what they're asking means to show you how light ray will go, how light ray will go. Okay, I will show you. Here also you draw one incident normal children. It will go outside, away from the normal. He's not asking one second. Question is, just mark the angle wherever necessary. That's it. They didn't ask you any angles also in this question. In this question, they did not ask you any angles. Just you have to mark the angles like this, and away from the normal like this. That's it. Okay, children. So like this, they have asked the questions. So okay. One question, two numericals are actually. We'll do two numericals also. Then you'll feel happy. So I'm telling two numericals without rubbing them. First numerical. A ray of light incident at an angle of incidence is 45.8 degrees. Angle of incidence is 48 degrees. On a prism of refracting angle 60 degrees. Angle of prism is 60 degrees. Suffers minimum deviation. Minimum deviation is seen. Children, during minimum deviation, what happens? Anyone can tell? I is equal to E, R1 is equal to R2. During minimum deviation, question is calculate the angle of minimum deviation. So children, what is angle of minimum deviation formula? Children, D is equal to I plus E minus A. But during minimum deviation, these both are equal. So deviation is equal to I plus I minus A. So 2I minus A. 2I means 2 into 48 minus 60. That is 96 minus 60. That is 36 degrees is the angle of minimum deviation. DM means angle of minimum deviation is 36 degrees. Whatever I told, you have to apply like this. No sir, we didn't understand this. One more sum I will tell children. What should be the angle of incidence? What should be the angle of incidence for a ray of light which suffers minimum deviation? Children, minimum deviation of 36 degrees through a equilateral prism. What do you mean by equilateral prism, anyone? Angle of prism is 60 degrees. Angle of prism, this will be 60 degrees. Equilateral prism means. Question is find the angle of incidence. Will you tell or shall I do, children? Anyone will tell or shall I do?
Sir, you can go ahead.
D is equal to I plus E minus A. During minimum deviation, these both are equal. D is equal to I plus I minus A. During minimum deviation only. Okay, so D is equal to 2I minus A. 36 is equal to 2I minus 60. 60 goes is there, 96 is equal to 2I. 2 goes down, I is equal to 48 degrees. The reverse question of this converse. So children, like this, we have to do various questions, prism, activities. So please go through them. And this lesson is over. Thank you so much.